Our next presenter is Tim Hall from Mac Media, and he's here to talk about NMOS at scale. So take it away, Tim.
Good morning. Firstly, apologies, I'm not the build speaker, but secondly, congratulations for finding the room. Took me a while. So what I'm here to talk about, who am I, why am I here? So I'm based in the UK. I'm now a consultant, but I used to do some real work when I used to mix audio. I then went into system design, station builds, always thinking about workflow control, never forgetting the audio, so intercom is always a big part of what I get involved in. I've now been a part of several IP projects with many different technology stacks. We started with 2022-6. We've done a lot of 2110, AS67, and some Dante along the way. And as I say, a mixture of control and orchestration and technology stacks as part of that. So what am I going to talk about? Well, I'm going to talk about a real-world implementation that I'm still involved with. What are the issues that we found along the way, and how might we improve matters? So you can read this on the NMOS website. This is just some highlights of what NMOS sets out to do. Largely, it does. But I'm going to concentrate really on the last two bullet points about finding, connecting, configuring, and how well does it scale. As I said, I'm going to talk about a real-world implementation. We've got 30 plus vendors across multiple sites, 2 large data centers housing the back-end processing, mixture of NMOS and native API control, and some 300,000 senders or receivers, senders and receivers combined. A third of those are NMOS. That's quite good. From the previous project I did, where we had 4 devices that were NMOS, as in 4 instances of one thing, sitting in an MCR. So you know, we've achieved a lot with NMOS. We've got a little bit of a constraint. The vendor that's doing the orchestration isn't using a registry. That means we need to go and discover every device ourselves. That's proved to have added somewhat of a configuration burden, but it does give us very tight control on letting things onto the network. So in order to make it work, we've had to create an offline data model and the tools to gather, process, and prepare configuration for the devices that we're going to control, the orchestration engine itself, and the higher level control system. It's given us a single point of good data that can then be reused for different uses. So, some more constraints. Our orchestration layer GUI only displays a single label for an object. You've got to drill down if you want to find out more stuff. And that label in NMOS terms is inherited from ISO 4. We can override it, but the big problem is when you're adding lots and lots of items, how do you actually figure out what's what? And I'll come back to some examples of how labels can be really confusing. Our orchestration layer is not using logical grouping. The sheer amount of data makes navigation through the system hard, very hard. Finding stuff is difficult. The concept of having 2 data centers gave us some geographical resilience, but in order to make the workflow and the operation work, yes, they're separate, but they need to be interlinked at a certain level so that we can make use of resources that sit in both of those data centers. This may sound like a silly thing. The higher level control system uses an integer-based model for dealing with routers, because it still thinks about routers. Well, the world's moved on. We don't use integers anymore. We use GUIDs. I guess another constraint, it's an extremely long project. We've been going 3 years, and We're now on air, and we're still growing the system. Okay, so some of the issues we found. As I've said before, troubleshooting gets challenging using native ISO4 labels, especially when those labels are in a mixture of formats and presentations. Not all vendors are using natural grouping, so there aren't many clues from looking at raw ISO4 information to figure out, okay, you've got this thing and it's got some devices and it's got some senders, but how are they linked together? I don't know, because your labeling is weird and you're not using logical grouping. Some NMOS implementations make it difficult to distinguish between instances of a given device type. What do I mean by that? Well, if I plug 20 CCUs in and they all say, hi, I'm a CCU, well, which one's which? Oh, well, yeah, but I'll tack on the serial number. Yeah, okay. Our project has been going 3 years. That means 2 of those years we were configuring it remotely. Not so easy to go and look for the serial number when you are 200 miles away. So large-scale implementations take time. We need clues to help us identify individual things and items, groupings, to ease our configuration burden. Another issue we found, and this is a regular occurrence, when a GUID changes, for whatever reason, it's quite difficult to replace that object because that's the primary key for that object. Well, when one GUID changes, it's difficult. 100 GUIDs change, yeah, even more difficult. So, yeah, not good. When I'm modeling a new device, we fire that device up. I point some of my tools at that device and find out, okay, well, it says it's got 1 node and it's got 3 devices and each device has got some senders and receivers. Well, that's how it is at the point in time that I'm looking at it, but I have no idea what will happen if I change the running mode of that device from a UHD personality to an HD personality. I have no idea what's going to happen if I update to the latest firmware. The vendors don't really help me. They don't give me a sheet which says, this is the structure we use, and this is the structure, how the structure might change if you change the mode of the device. And completely coincidentally, last week, we're about to bring on a new device. The vendor sent me a sheet which explained exactly that, exactly what I've been asking for. And I didn't even prompt them. GUIDs. GUIDs change. Okay, so there's 2 issues we've had with GUIDs. One, non-unique GUIDs. Well, it's not a GUID. Okay, it really just upsets my OCD when they're not unique. When I'm saying not unique, what we've seen is reuse of a given GUID on a different instance of the same device. It just looks odd, especially when these GUIDs are sequential. Again, they're not really unique, not really guaranteed unique. So it's not much of a problem if they're not unique within themselves. Obviously, when you fully qualify them, it has to be unique. But one of the biggest issues we found are non-persistent GUIDs. I reboot a device or I upgrade its firmware. Oh, look, all the GUIDs have changed. Worse than that is if I reconfigure the device and all the GUIDs change, because that reconfiguration might be an operational reconfiguration that jumps from UHD to HD. It's particularly been an issue with audio devices. So, labeling schemas. So, in my head, we've got 3 different ways of labeling things. So here's some examples of senders or receivers that are fully defined by the vendor. So what does the first one mean? It means nothing. I can't work out what that really means unless I've got a lot of knowledge of the device that's sending it. And in that particular case, that label isn't unique. It might change if I reconfigure that device. Second one's, okay, slightly easier. I can see what it is. It's going to receive some video, and that looks like it might have a bit of serial number in it, so that might give me a clue, but I've still got to go and find out what that is. So here's one that's partially vendor defined. So the first bit, this bit here, I can find. The last bit, what on earth does that mean? No idea. Trial and error. Spent a good couple of hours trying to work out which one was which, and then found out that different versions of firmware had different types of label on the same cards in the same device. Customer defined. Well, that doesn't offend my OCD because that's nice and uniform, and it sort of tells a story. For customer defined labels, there are generally 3 different ways of allowing the customer to do that. So the vendor will allow you to type them directly into the config tool. Okay, if I'm typing in 5, that's not a problem. If I'm typing in 500, I don't want to do that, thank you. Maybe there's an API, that would be good. Maybe I create a pattern and say, well, okay, I know you've got 100 audio senders, let's use this pattern with placeholders. Or I could upload a lookup table. Some of the devices that we've seen running on software, I can just post a JSON file into the device's file system, and I've created a lookup table. So now, when I look at NMOS data, I can actually see some labels that mean something to me. So our vocabulary that we've chosen, this is our solution, this is not something we're advocating to be a fixed vocabulary. We're saying this suits our purpose. So every object in our design, whether it be a physical thing or a logical thing, so it might be an example here is a camera control unit, it could be a server, it could be a sound mixing desk. We give it a code, which we call a unique ID. Where it is, that's 5 digits. What it is, it's a CCU. And which CCU is it? Oh, it's 1, it's the first one. Doesn't mean it's camera 1 in any particular control room. It's just the first CCU in our infrastructure. So this gives us a context for every object in the design. And in fact, those UIDs appear on AutoCAD schematics. They appear in IP address tables. They are our way, our shorthand of knowing which object we're talking about. Usually, not always, the device gets that name. We can put that UID into the device, and it becomes the ISO4 node label. But not always, because sometimes there's some restrictions on the characters that we can use. Now, maybe you might argue that we shouldn't have put slashes in our unique IDs, but we didn't know what we didn't know when we started, and you're probably right, we wouldn't have. But that physical or logical device might have several nodes, so we might need further qualification to say, well, actually, this is #1, #2, #3 of our CCU 001. So then, for senders and receivers, we've mandated the format of the sender and receiver text using a shorthand of essentially recreating the logical grouping, but in a label. So if you think of it as spigots, yeah, we're still thinking about what we'd have if we had SDI and a baseband handoff. So spigot 1, that's logical grouping. Everything that says SO1 is related within within our IP system. And then for the essences, we've just chosen some labels, some letters that mean things, video, audio, metadata, X for JPEG XS. So this is really a plea to vendors to say, as an implementer, what I really need is a clear definition of what your node device sender receiver schema is and how that might change at runtime. Please implement natural grouping. Okay, natural grouping is not mandatory, but it's a pain if it's not there. And at least one of the systems that I've been working with in the last 3 years, it becomes incredibly difficult if natural grouping isn't available. We've made some progress. The Wuppertal JT&M testing event that took place earlier this year tested 74 nodes, 65 of those passed with regard to the natural grouping. But that's still only 2/3. So again, change the GUIDs when really when it's necessary. Don't change them just because it really makes implementers' life difficult. And give implementers the opportunity and tools to choose a labeling schema that fits their project facility. I've given one example. You don't need to do that. It was our way of providing a unified approach when we go to the orchestration layer so that everybody has the same vocabulary. This is the very thing, the very flow that we can all talk about in the same way. And that makes troubleshooting much easier. So that's my plea to vendors. So what's happening within AMWA? We're discussing how we might encourage or enforce some of these things within implementations. As a first step, we've worked up some user stories which try and set the stage for how a piece of work might be able to deliver some tangible results. So at that high level, I just need a clearer way of differentiating between objects that appear in the tree. Because when we leave vendors to decide, there's just too much ambiguity. That's me. Any questions?
Okay.
That's super. Excellent.
All right. Nice.
Good.
Thanks for bringing
Thank
us some. Thanks for bringing us some real world experience there, Tim.
That's okay.
Appreciate it, and be happy to have you join us for the rest. Okay. Thank you.
Thank you.
Okay.